This website is a great tool for editing PDF documents. I learned about this maybe a couple weeks ago, and I haven't experimented it until today. And it's just something that you might want to consider in the future in the event that we continue distance learning in the fall. So all you do is create an account, and it's free, so you don't have to worry about it. And I think I used my Preuss email to get on. So I'm going to open a file from my computer, and it brings up the PDF, and then you can write on the PDF and then save it and then send it as a way to submit your work. So the nice thing about this feature is that sometimes you don't want to waste paper, or you don't want to draw a graph by hand. And the main reason why I wanted to do it today on Kami app is because in the past, when I teach a lesson on a whiteboard provided by Zoom, there's no grid lines. And when there's no grid lines, my graphs look a little sloppy. So I wanted to use something that had graph instead. So for system equations number 2, here's the examples. I created 4 example problems. And I also input the word of the week at the very top, so you can write the word of the week there. And we'll talk more about that later. Using the substitution method to find the point of intersection for each system of equations. Check your work by graphing. Show all work. So before we begin, there are 3 steps to applying the substitution method. And one of the reasons why we want to learn a different method besides graphing and tables is the fact that sometimes graphing can be an issue because the point, you can't see exactly where they intersect. So we're going to try another method called the substitution method, which all involves algebra. I'm going to write the 3 steps at the very top of the page so that you can see what they are. So step 1, you want to isolate the variable. So isolate a variable. And you'll see me apply all these steps in a bit. Step 2 is to make sure we substitute the isolated variable into the other equation. And then step 3 is we solve for x and y to find the point of intersection. So isolate the variable first, then substitute the isolated variable into the other equation, and then solve for x and y to find the point of intersection. I said a lot, so now I'm going to show that through examples. So let's say my first equation is y equals 5, and my second, I'm not liking that color, get a darker color. Let's go with blue. Okay, so my first equation is, let's see, how do I undo? Oh, wait, undo button's at the top. Okay, so my first equation is y equals 5, and my second equation is negative 12x minus 4y equals negative 8. First step is isolate the variable. Which of these 2 equations has an isolated variable? The blue or the red one?
The blue one?
Yeah, the blue one is isolated. Y is by itself. There's no x's in the way and no numbers. And the second equation, the red equation, there's the 12, the negative 12 is in front of the x, the negative 4 is in front of the y. So it's not isolated. So we can skip step 1 because it's already isolated. Step 2 is substitute the isolated variable into the other equation. Keyword is other. So I'm going to write the other equation first, negative 12x minus 4y equals negative 8. I take this equation, y equals 5, and plug it in to what y equals. So we now have negative 12x minus 4 times y, which is 5, equals to negative 8. Now we just simplify this and we get negative 12x, 4 times 5 is 20, equals negative 8. Then we add 20 on both sides to get x by itself, because step 2 was to substitute the isolated variable into the equation. So we just did that. We took the isolated variable and plug it into the other equation. Step 3 is to solve for x and y to find the point of intersection. So we already know what y equals. Now we need to solve for x by adding 20 on both sides. And we get negative 12x equals negative 8 plus 20 is 12. Lastly, we divide by negative 12 on both sides. And 12 divided by negative 12 is negative 1. So now we solve for both x and y. And our point of intersection is going to be abbreviated as POI, point of intersection, is going to be x comma y. And our coordinate would that be in this case is negative 1, comma, and our y was 5. Any questions? So just to recap, first we isolate for the variable, which is y equals 5. Second, we substitute the isolated variable into the other equation, y equals 5, plugged into the second equation. Then we solve for x and y to find the point of intersection. We already know y, so we solve eventually for x, and we got x equals negative 1. So our point of intersection is negative 1 comma 5. Now we're going to try to graph it to see if this point of intersection is correct. So I'm going to draw my x and y axis. And I'm going to scale by 2s just so that I can fit all the points. So this is going to be 2, 4, 6, 8, 10, 2, 4, 6, 8, 10. So we take our first equation, y equals 5, and we want to graph that. So y equals 5. So this is at 2, 4, y equals 5 is right here. And then any x we plug in, it won't change the equation. So if I put x equals 10, y is still 5. And if I put x equals negative 4, y is still 5. So now that we have that, we are going to graph our line. And it should be something like that. Now that we have that equation, we're going to graph our second equation, which is negative 12 negative 12x minus 4y equals negative 8. So this is in standard form. We can't graph it yet because we need it in slope-intercept form. So we're going to add 12x to both sides. And we get negative 4y is equal to 12x minus 8. Then we divide by negative 4 on both sides. And we get y is equal to 12 divided by negative 4 is negative 3. X and minus 8 divided by negative 4 is going to give us positive 2. So now we have both equations in slope-intercept form. And to graph the second equation, we start with the y-intercept of 2. And then I draw slope triangles where the change in y is negative 3 and the change in x is positive 1. So go down 3, 1, 2, 3, and 1 to the right. Down 3, 1, 2, 3, and 1 to the right. Down 3, 1, 2, 3, 1 to the right. And if I want to go the other way, I go up 3, 1, 2, 3, and 1 to the left. So then we can draw our line for the equation. And you'll see that our point of intersection, right? Whoops. Our point of intersection is right here. And that coordinate is at -1, +5. So the graph, -1, 5 as the point of intersection does match the substitution method, which is -1, 5. Any questions? As always, if you feel like you need another lesson on it, this is always pre-recorded, so you can watch the video again. So now we're going to try the second example. Substitution method first. And x equals 9 is one of our equations, and -7x minus 9y equals 18 is our other equation. So isolate for the variable. The first equation is already isolated for x. And then we plug it into the second equation, the other equation. So we have -7x minus 9y equals 18. Instead of writing x, I'm going to write in 9. So we substitute it in. And then I write the rest of the equation. -7 times 9 minus 9y equals 18. -7 times 9 is -63. Minus 9y equals 18. So once we substitute the isolated variable into the other equation, we solve for the variables x and y to find the point of intersection. We already know what x equals. Now we're trying to solve for y. So we add 63 on both sides. To get y by itself, get -9y equals 81. Then we divide both sides by -9 to get y by itself. And y in this case, 81 divided by -9 is -9. So our point of intersection is going to be our x value, which is 9, and our y value, which is -9. If you have questions, please unmute yourself. Okay, we'll construct a graph. Can you guys see my writing on the screen? Just want to make sure.
Yeah.
Yes?
Yeah.
Yes.
Okay, so similarly, this is the point of intersection 9, -9, so I'll probably have to scale by 2s, but let's make sure that my equations are fine first. So x equals 9. I don't need to do anything there. That's my first equation. But my second equation needs some work. So -7x minus 9y equals 18. And I need to put this in slope-intercept form. So add 7x on both sides. And we get -9y equals 7x plus 18. So slope goes first, then the y-intercept. Then divide both sides by -9. And my equation is going to be 7 divided by -9. So -7 over 9x. And 18 divided by -9 is -2. So my y-intercept is going to be at -2. And I can scale by 2, so it looks like, because x equals 9. Yeah. So scaling by 2s. 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. So scaling by 2s, x equals 9. So I'm going to find where x is right here and 9 is over here. And if I said y is 10, x will still equal 9 because y is not in the equation. And if a y is -6, x will still be 9. So -6, 2, 4, 6, it'll still be 9. And then you can graph your line. And that will be the wrong color. So there's my line. And now I need to graph my second equation, which is -7 over 9x minus 2. So I start at -2. I go down 7 and to the right 9. So 1, 2, 3, 4, 5, 6, 7, and 2, 4, 6, 8, 9. And then over here I go up 7, 2, 4, 6, 7, and then 9 to the left. And then I connect my points to form my line. And my line should look something like that. And you'll see that the point of intersection is happening right here. And that's at 9, comma, -9. And that matches with what we did with the substitution method. Any questions? Okay. So this next equation, we have one equation where y is isolated already by itself, and the other equation where y is also isolated by itself. So when you have that, we can write it as the following. We know that y is equal to y. So instead of writing y, we can just write in 6x minus 1, and that's equal to -4x plus 9. Y equals y, and 6x minus 1 is equal to -4x plus 9. So now we can solve for the variable, since we already isolated for the variable. And we substituted, so we're on step 3, which is solving for x and y. So we can add 4x on both sides. We get 10x minus 1 is equal to 9. Then add 1 on both sides. And you get 10x equals 10. Or in this case, x equals to 1. Now that we solve for x, we need to solve for y. So we'll take this answer, x equals 1, and plug it into either of the equations. You can choose either one. I'll just choose the first one. So y equals 6x minus 1. And we know that x is equal to 1 from above. So now we have y equals to 6 times 1 minus 1. 6 times 1 is 6, minus 1 is 5. So y equals 5. Therefore, our point of intersection is going to be our x value, which is 1, and our y value, which is 5. Questions? Miss Abby, if you can let Jaden in. Okay, so next one. Both of these equations, you'll notice that they're already in slope-intercept form. So we actually don't have to translate them into slope-intercept form when they're already there. So we'll just start graphing these two equations. This is +9, so I'm going to scale by 2's again to get all my coordinates. 2, 4, 6, 8, 10. So starting with the blue equation, we have 6x minus 1. So I start at -1 as my y-intercept. I go up 6. So 1, 2, let me label my y-axis first. Okay, so now that the y-axis is labeled, I'll go up 6. So 1, 2, 3, 4, 5, 6, and then 1 to the right. Then I go down 6. So 1, 2, 3, 4, 5, 6, and 1 to the left. Because my change in y over my change in x is up 6 and to the right 1. Now we can graph our equation by connecting our points. And then my second equation is going to be starting at +9 for my y-intercept, and then my change in y over change in x, down 4, 1 to the right. So 1, 2, 3, 4, and 1 to the right. 1, 2, 3, 4, 1 to the right. 1, 2, 3, 4, 1 to the right. Then you connect your points, and you should get a line that looks something like that. And the point of intersection is right here. Whoops, wrong tool. Point of intersection is right here, and that looks to be at 1, 5, which matches with the substitution method. Any questions? Okay, so the last one. This one's a little different because both equations are in standard form. So both equations are in standard form. One of the first things we can do is try to get them in slope-intercept form, because that will help us with our graphs later on. So -2x plus y is equal to -18. Add 2x on both sides to get y by itself. Y equals 2x minus 18. Our second equation is 3x plus 2y equals 6. Subtract 3x on both sides. Get 2y equals -3x plus 6. And then divide by 2 on both sides. And you get y is equal to -3 halves x, and 6 divided by 2 is 3. So we have both our equations in slope-intercept form. Might as well just graph it too, since they're already done. So let's add in the x and y axis. And then we have it at 2, wrong color. So we have it at 2, 4, 6, 8, 10. Whoops. Notice how the y-intercept is at -18. If I scale by 2s, I'm not going to get to -18. So I'm actually going to try to scale it by 3s. 3, 6, 9, 12, 15. So 3, 6, 9, 12, 15, 18. So this is -18 down here. So 2x minus 18 is the first equation. So I start at -18 for my y-intercept and go up 2. So 17, 16, and then 1 to the right. And my 16, so go up 2, 15, 14, then 1 to the right. Up to 13, 12, 1 to the right. So -3, -6, -9, -12. So I have my graph right there. And we'll connect my points. And the point should look something like this. And then for my other graph, I have -3 halves x plus 3. So I'm going to start at 3 for my y-intercept. And that's up here. Wrong color. And then I go down 3 and over 2. So down 3 over 2. Down 3 over 2. So forth. And then up 3 and over 2 to the left. And then connect my points. And we should have a graph that looks something like that. The point of intersection looks to be around here. That is at 6, -6. Let's see if that's true by using substitution. So we have the first equation is 2x minus 18. And my second equation is -3 halves x plus 3. So this problem is very similar to the third problem, which is where you set y equal to y. 6x minus 1 is equal to -4x plus 9. So we set y, 2x minus 18, equal to y, -3 half x plus 3. Then solve for x, and we will add 18 to both sides. 2x minus 3 halves x plus 21. 2x equals -3 halves x. And then we add 3 halves on both sides, which is the same thing as 1.5. So 2 plus 1.5 is going to be 3.5x. So 3.5x is equal to 21. And then we divide both sides by 3.5. And I believe it ended up being 6. So 21 divided by 3.5 ended up being 6. And then once you get x equals 6, you plug it back into the original equation, either one. Let's say I plug into the second one. Sorry for being a little messy, just running out of space. So plug in x equals 6. 3 times 6 plus 2 times y equals 6. 3 times 6 is 18 plus 2y equals 6. Subtract 18 on both sides, and we get 2y is equal to -12. Divide by 2 on both sides, and you get y is equal to -6. So that matches with what we have earlier. The point of intersection is going to be x is 6, and y is -6. And that matches the graph, 6, -6. Sorry for the mess on the second one. If you watch the pre-recorded YouTube lesson, it's a lot cleaner. Any questions?